Alright, in this video, I'm going to be talking about air pressure or barometric pressure. This is a different name for the same thing. Okay, if you think of an air molecule, okay, just like this, each air molecule weighs a certain amount. Okay, imagine a molecule is like a concrete brick. Okay, if you have lots of molecules stacked on top of each other, okay, the ones at the bottom are going to be feeling a lot of weight, whereas the ones at the top are going to be just the weight of one molecule or one brick, whereas the bottom ones are going to be feeling all that weight at the bottom. Okay, this is basically how air molecules act in the atmosphere. Alright, so these molecules exert a certain pressure, okay, out on the Earth's surface or in the atmosphere. Okay, depending on how many molecules are stacked on top of each other will depend on the air pressure at that location. Okay, air pressure is measured in a unit called hectopascals. Alright, now we know a little bit about air pressure. Okay, we can talk about wind and what causes wind. Okay, so basically the sun heats the land, okay, at different rates. Okay, so if you think about as the Earth rotates, okay, and the sun comes into contact with different parts of the Earth's rotation, okay, the ground's going to start heating up at different rates. Okay, so the morning here might be cool, but over there, okay, where the sun's already risen, the temperatures are warmer. Okay, that's going to create different temperatures at different locations. Other things that create temperature differences are the surfaces of the Earth. So if you imagine like a big black car park, okay, the temperature there is going to be a lot hotter than over a nice cool ocean. Alright, so as air is warmed up by the sun, okay, it becomes lighter, it becomes less dense, so it tends to rise up. Okay, as this air rises up, cooler air over here that hasn't been heated, okay, is going to come in underneath to fill up the space where the hot or warm air, or the air has been before. Okay, this is going to come in and fill up the space. Okay, basically, this heating of different parts of the Earth's surface is what causes our air to move around, which is wind. Okay, air molecules moving around is our wind. Okay, so when we're thinking about air pressure, okay, a region of high pressure, okay, is always going to move into a region of lower pressure. Okay, think of a balloon. Okay, when you blow up a balloon, okay, it's going to have a lot of pressure inside of it, okay, a lot of air pressure compared to the lower pressure air around it outside. So when you let go of that balloon, okay, the high pressure inside is going to try and escape. Okay, that's what causes a balloon to run around the room. Alright, this change in pressure from one region to another is called our pressure gradient. Alright, when we look on our map, okay, on our weather map or weather chart, okay, the lines, okay, these are called isobars. These show us the pressure gradient. And the extent, okay, of that pressure gradient, or how close the pressure gradient isobars are together, will determine how strong the wind is. So if we have isobars that are really close together, okay, it's going to be really windy, but if we have isobars that are really far apart, okay, it's going to be quite calm winds.